Yeah, now I did not talk about what you need in order for this to work. I'm going to read it out of the book, okay? Because there are some issues that we run into. Where's the evaluation theorem? Okay, f is continuous on the interval is all we need. Well, there's some stricter things that you need later. Yeah, because there still is a way to find the area underneath a curve if it's not continuous, and you'll do that in Cal 2. So like when you have a function that does something like this, let's just take like 1 over x, looks like this, right? You could start here maybe at 1 and then try and find the area all the way to infinity. Stay tuned. So it doesn't have to be continuous. You can have discontinuities and you can still integrate. But for now, let's just say it's got to be continuous. All right, so what am I going to do? Set up a definite integral, right? Let me just write down the definite integral. What's my lower limit of integration?
0.
Upper limit? What's the integrand?
F of x.
Which is just x, and then my differential dx, right? That's the setup of the definite integral. Now, if you follow what I wrote just a second ago, I want capital F of x with a bar in a and b, right? So what is the antiderivative of this? 1/2 x squared, right? Now, normally you would say plus c, but you don't need the plus c with a definite integral. You don't, and I'll show you why after we finish it. So no plus c here. I draw a bar, and I put 0, and I put 6. Understand? Now, the next thing is capital F of b minus capital F of a, right? So I'm going to take the b and plug it into that antiderivative. So this notation is just like, gives you an opportunity to write down what the antiderivative is first, right? That's all that is. Then we're going to plug 6 in. 6 goes first. Subtract from it what you get when you plug in 0. So let's plug in 6. That's 1/2 6 squared, right? Subtract from that 1/2 0 squared, which is just going to be 0, isn't it? So you get 18.
What? Units or unit squared?
What, yeah, the unit, we would have to know what things were being measured in.
But it should still be squared though, right?
No, well, what's the unit though? I don't know what the unit is, so I can't say. If it's feet, it would be square feet, 18 square feet.
Oh,
Yeah.
squared.
It's unit, at this point, it's unitless, all right? All right, understand? Pretty straightforward? Now, I want to show you a picture of what we just did. F of x equals x is the diagonal, isn't it?
Yes.
And I only drew it between 0 and 6. And that's a triangle. And isn't the height of the triangle also 6? Because when you plug in 6, it spits out 6. So what's the area of that right there? Well, what's the area of this square? 36. Let's take half of it, should be 18, right? It matches, right? It matches. That's not a coincidence. I mean, that's the way it's going to be. Now, you could have done this problem without calculus, right? Just draw it and say, oh yeah, that's a triangle. Good, right? Let's change the problem. X squared. Now you can't do this without calculus, because now your picture looks like this. Well, yeah, it's a parabola, so we're going to be trying to find the area underneath. It's going to go like this, right? Here's 6. Here's up here, it's what, 36 up here? And I'm trying to find the area below this. What's that area? There's no way you can do that with triangles, right? So we're going to use the evaluation theorem, and that beautiful mean value theorem allowed us to get that to be able to compute this. So all that changes here is what? Squared. All that changes here, 3 and 3, right? The antiderivative is 1/3 x cubed. And this changes to 3 and 3. This changes to 3 and 3. And we get, what's 6 cubed?
36 times 6.
Mm-hmm. Which is? Is it 216? Do you divide by 3? Okay.
It's 72.
Is it 72? I'm hoping you all agree with that. 72. And then what about this? 0. So the area under there is 72. One more and we're done? One more?
No, it's past. Well, is this going to be on their exam?
Yes. I'm going to. You don't. I think this is actually relatively. I'm not going to ask you to like derive the formula for me like I derived it for you. Look, at the end of the day, all I'm doing is asking you to find the antiderivative and plug in 2 numbers to it, right, and subtract them. That's all this is. I'm going to keep the functions clean. I'm not going to be like some crazy. Yeah. So, what about this one? How about sine x? From 0 to 2 pi. Try it yourself. Oh, hey, why is the plus c not there? I didn't say that. Remember when we did the antiderivative, we had 1/2, that first one, x squared, and we said we're going to go 0 to 6? If we had put plus c here, then when we plug in 6, we're going to get 18 plus c, right? And then when we plug in 0, you'd get, minus, is 0 plus c, and the c's would basically cancel each other out. And that would happen every single time. Your constant would go away. So we just don't even put it there. All right, try that on your own. When someone has an answer, let me know. What did you get? 0. Okay. We got another 0 over there. Just be careful with that antiderivative. If you finish that one and you're bored, try it again, but this time go to 0 to pi instead of 0 to 2 pi. See what you get as an answer there. I just worked out the first one up here, so When you take the antiderivative of sine, it's negative cosine. You want to evaluate it from 0 to 2 pi. So first you plug 2 pi in here. So you write everything you have here. Negative cosine, replace the x with 2 pi. I like to put that in parentheses. That's f of b, capital F of b. Minus, in the formula there's a minus, capital F of a, again, take this right here, negative cosine, and plug in 0. And then you just have to know the value of the trig function. So cosine of 2 pi is 1, but then you make it negative, so negative 1. Cosine of 0 is also 1, but make it negative, so negative 1. But you're subtracting the negative, so it becomes plus, and they cancel, you get 0. Why in the world is the area under the sine curve between 0 and 2 pi 0? Because it goes up and then it goes down like that, right? So it's actually this integral, right, is counting area above the x-axis as positive area and area below the x-axis as negative area. It actually takes into account whether or not you're above or below. So this actually gives you the net area. All right? It gives you the net area underneath the curve. And that's dangerous because, well, what if you don't know that the curve dips below the x-axis like that? It could come into play, but for now, don't worry about it. What about this? You run through this one? You got positive. You should have a positive number. I'll run through it. It's going to be same setup, but same antiderivative, right? 0 to pi instead. So first you plug in pi, negative cosine pi. Then subtract from that what you get when you plug in 0. So what's cosine of pi? Cosine of pi, negative 1. But then change it, right? So positive 1. This is 1. Minus cosine of 0 is 1, change it to negative, so negative 1, so you get 2. See the difference between these two problems? So this actually tells you that the area in this first arc of sine, this first arc that you get, the area under there is 2. Isn't that kind of strange to you that the area under that is such a nice number? To me, that's always been awkward, that that's just such a nice number. All right, well, I actually assigned you some problems out of this section to practice. All right, just on the email I sent you today that lists problems for you to look at in the book, I picked some problems out of this section for you to practice. All right? So let's talk about this final. This is actually the first time I'm actually going to think about it in depth. Are there any questions you have?
How many questions?
How many questions is it?
Yeah.
I haven't written it, so it's hard for me to answer that question. I don't want to lock myself into a certain number. Let me kind of... Oh yeah, your exam is on... What's today? Wednesday? Your exam is on Monday. I know, y'all don't get much time. It's on Monday. It starts at 11. And it goes until 1:45. So you're going to have 2 hours, 45 minutes for this final, which is about, what, 160 something minutes? So probably about 160 problems, about a minute a problem. Yeah.
What's the subject of like the chapter that most students kind of mess up on the final review?
Just going back and reviewing the stuff from the beginning. I think people just kind of dump it at some point. They just brain dump it. I would anticipate, I'm just looking here at the different chapters. Let me do it this way. Chapter 1 is limits, right? Chapter 2 is derivatives. Chapter 3 is inverse trig. But this, I'm going to put L'Hopital because that's in here. And where's the section on, hold on. $163. Let me just double check this. 163. Yeah, L'Hopital, logarithmic differentiation. That's where you had to bring in the log on both sides. All right, that's the main concepts in that chapter. And then you have chapter 4, which is applications. And then chapter 5 is integrals. And there's actually some integral stuff in chapter 4 also. In specifically 4.7, okay, is antiderivatives. So if I was looking at this just from a broad perspective here, let me eliminate some things, all right? Things that will not be on the test. I'm not going to ask you to sketch a curve, all right? I'm not going to tell you to do all the steps to sketch a curve. You did those as take-homes, and they take too long. And what I will ask you is to find where a function is increasing, decreasing, concave up, concave down, inflection points for a relatively easy function. It's not going to be crazy. But you need to be ready for it, though, right? If there's some quotient rule in there or some chain, just be prepared to set it equal to 0 and all that. Newton's method is not going to be on the test, okay, so I'm not going to ask you to do Newton's method. Mean value theorem will not be on there. Nope. So in I don't know why I'm starting with 4, but in chapter 4, I'm thinking, find the max and min on a closed interval, so like a closed interval method problem, and then another problem that's going to be increase, decrease, concave up, concave down. So like one of each of those. Optimization problem, I do intend on having an optimization problem. I intend on those being very similar to what was given for homework. The optimization 231, whoa, is it 231? Yeah. I'm talking problems like in the homework, right? Farmer problem. What did y'all think of the ones that was like the sum of two positive numbers is 16? What is the smallest possible value of the sum of their squares? Did y'all?
Just gotta do it over again, man.
Yeah.
It's not that hard, but just practice.
I will not give you anything like, find the largest cylinder that can be inscribed into a sphere. I'm not going to do anything like that to you. All right? But expect at least one optimization problem. And I would say from chapter 4, that should probably make up about roughly, don't hold me to this, okay? Maybe like 30% of the test. And I'm going to say that integrals and antiderivatives, probably another 20% here, maybe 25. Let's say 25. That's things like find the antiderivative, right? Use the power rule backwards. You need to know the antiderivative of cosine is sine, things like that. I do plan on having at least one substitution problem in there. So I gave you 6 problems to look at, right? look in that section. I would just look through some of the problems in that section, because I'll probably pick something like that in there. I'm going to give you a problem where you have to find the area under a curve. It's going to be kind of like what we just did. Okay?
And we need to know that formula, right? The definite interval.
I guess I can provide that since your test is on Monday, and I'm just giving it to you today. I don't mind providing that for you. But you should just get it memorized by Cal 2. Let's see, L'Hopital derivatives. Let's just round this off. Let's just do this. I'm going to say 30, 30. I'm going to say that like 60% of the exam's probably going to come from these two chapters. And then I'll go back and do the other 40% from these. Probably maybe like 20% here, chapter 3. I know this looks real crappy, but 10% here, 10% here. I will ask you to do some limits. That would be harder to do with L'Hopital. Like, there are some limits where it's just better if you just remember how to do it. Like come in with the conjugate, something like that. And when I went through and I sent those problems to you today, I was very specific about the types of problems I wanted you to look at. So I would look at those problems that I sent in the email today in regards to the limits. The derivatives, you will have to do at least one derivative where it's using the definition. I'll provide you with the definition, okay, so you don't get too upset about it. But that's the one where you have to do the limit, h goes to 0. But again, I'll make it a nice function that's not going to be complicated. You just need to be able to run the quotient, the difference quotient, not quotient rule, the difference quotient. And remember, you're trying to get the h to cancel, and then you let h go to 0.
Is that the one that's like h plus 2 to the third over h? And then
That's the one's limit h goes to 0 of f of x plus h minus f of x all over h. That's your definition of the derivative.
Is that the one with 2 different methods?
There's 2 different ways to do it. That's right. And you could use the other formula, which is limit x goes to a of f of x minus f of a over x minus a. And when you do that, I'll ask you to compute the derivative by hand. Good news, you can always check your work by using the rules to verify that you got the right derivative. And then I'm going to ask you to find this. Do not screw this part up. When I do this, I'm going to ask you to find the equation of a tangent line. You're a Cal 1 student. You're wanting to pass this class and get through it. Then you should be able to find the equation of a tangent line. And that's where you use the derivative as your slope, you use your point, and then you use the point slope formula from college algebra, which is the y minus y1 equals m times x minus x1. And that, we used a lot. Be able to do that. Implicit differentiation. Implicit differentiation. That's where you have when you can't solve for x or y. I also assigned some of these in the homework or in the problems I sent today. Like, how would you take the derivative of this with respect to x? So you go like cosine of xy, then you take derivative of what's inside. That's a product rule. And do you remember this is where the derivative of x is 1, but the derivative of y is y prime? Go back. Implicit differentiation. That's specifically 2.6. I've kind of locked myself in now to the test. So I can't tell you how many problems, but now I'm kind of 10 problems. No, you don't want 10 problems.
I don't want 10 problems.
No. And my just thinking through this, I'm thinking 20 questions sounds like it's right, but
I think 20 questions is right.
20, yeah, I don't know. That sounds right. I think anything under 15 wouldn't be long enough, and I think anything over 30 would be too long. So
will it? Never mind. Maybe you'll answer it if you won't. Will it be similar to like our test?
I haven't made the test. I can't, I can't tell you what it is if I haven't made it yet.
Like, do you think
The complexity.
Never mind.
Like the complexity
This is the final. So what I want to know is that you have a basic understanding of all of these concepts, which means I'm not going to challenge you with the hardest problems. I'm honestly looking at probably mostly the easier problems from the book type thing as the problems on the test. When you're taking the other tests, I'm looking to push you a little bit further because you're focused on that material only. So I expect that you can do some harder problems. Here, I just want to make sure that you remember how to take the derivative using the limit definition, that you remember how to do implicit differentiation, that you remember how L'Hopital's rule works. Because you don't want to walk into Cal 2 and be like, yeah, I passed, I got a B in Cal 1, but you don't remember any of this stuff. So you need to have some basic understanding of all of it. I don't know if that helps, but...
No, that
Any other questions?
Nope. How quickly will you grade the test after that?
You'll be the first test I give. And then my next test, yeah, so yours is going to be graded right away. Yeah. And I give another test on Tuesday and another test on Thursday. Yes.
Time to re-sign up.
Pardon me? Bonus questions? I hadn't even thought about it. Yeah, I can consider something. The one that was on the test? On that other test? All right.